Thank you for inviting me, and I'll just say it's multi-access edge computing, but we'll figure that out in a second. So while I have the pretty slide about why edge computing is important, and I'll introduce the group, and then I'll talk about why I really wanted to speak to this audience about edge computing. And then I'll have some conclusions. So, but while you're looking at this slide, or maybe, yeah. So, well, let me start with this, right? When you think about edge computing, it's really a cloud at the edge. And everything that we're going to talk about, and that I always talk about, is its location, location, location. It's just like in real estate. In fact, it is all about real estate. You're trying to put clouds in specific places so they're close to users, and that's what the ISG is about. Now, while we are talking about this busy slide, a little quiz. I know that a lot of you were in the multiplayer workshop yesterday, and Nurit explained what an ISG is within ETSI, so here's a quiz. What makes an ISG a particularly attractive group for industry to participate in, as opposed to a TC? I don't have ETSI swag. Those of you who may have seen me in another conference, I give away socks. But if you answer the question and you want ETSI socks, you give me a business card and we'll get them to you. Okay, no hands up. So an ISG is a structure that ETSI created to allow participation by industry participants who are not members of ETSI. So that allows us to bring more players into a group. And also, although with NFV and MEC, and probably CSM going forward, standardization is going to be an important aspect. They are structured to enable the market, so there's a bunch of other activities that we're going to talk about. So what do we actually do? We're focused on the APIs, and I'll talk more about what that means in a second. Really focused initially on the mobile market, so we started out as a mobile edge computing, but then we realized that everything we're doing really applied pretty much to all kinds of access networks. Thus, the change in name without a change in acronym. So while we publish standards in these areas, 4 important areas that are worth noting. We're on POCs. So proofs of concepts, which are now transitioning into what we called market or MEC deployment trials, MDTs, and that's basically, whereas a POC is really a lab demo or a commercial lab demo or a demo out in the field. This is a pre-commercial field trial or a pilot in some cases of edge computing in the market. We publish a bunch of white papers that kind of help the market understand how to put things together. Standards documents are not the easiest things to read, and they typically won't give you a full picture, so we do that. Very importantly, all of our APIs are available on ETSI Forge and GitHub as a tool for developers. And I won't talk a lot about service exposure APIs, but in this particular presentation, because this is a forum that's really much more focused on the management side, but these are really geared at the developer community. And so what we've done is we serialized all of them. They're available here, they're available on GitHub. And we're now developing a set of test compliance specifications and suites to go together with those. So if you are looking for those kinds of tools and looking for these APIs, look at forge.etsy.org. We have a pretty good membership. We're approaching 90. I don't think this is the most updated figure. With leadership sort of across the industry up here. So I chair this, I work for HP. The current vice chairs are from Nokia, Huawei, and Intel. We have a couple of operators that were quite active. In fact, Vodafone was a founding vice chair, and they just stepped down from that position. And Vayavi leads the test and the software development effort. And then we have a number of other companies that are actually active in the group. So it's a fairly small but very vibrant and active group. Oh, nice bug. Come on. What do we actually do? We have what we call framework documents, so requirements, architecture. Those of you who looked at edge computing, you've probably seen our architecture picture floating around, in many cases misused and misinterpreted, so I always make a case of point that it's a reference architecture. That's not a normative work product, even though it's a normative document. And a set of guidelines for how to write APIs in a way that's consistent with ETSI MEC. Again, particularly important for services, which I won't go much into here, but if you want to have a service, or if you have a vendor that wants to offer a service that doesn't have a standardized API, they can expose one in a way that's consistent with ETSI MEC. We have in our required API set in MEC 11 a means to enable applications to discover what that service is, for the service to advertise itself, etc. And then, not shown here, but we have a set of management APIs. So, right, so we have the enablement framework, the principles, this stuff. I could spend an hour talking about these things, plus the Forge, plus the white papers. But really, when I think for this conference, what makes sense to focus on is here. And that's the work that we're doing. Last slide on what the group is and does. If you look at our work product, this was our kind of phase 1/release 1, and you can kind of see the work that we've done. That ended about a year and a half ago. We concluded that work. We're now working on phase 2. And you can see the focus of phase 2 is evolution, including some key industry segments. We're doing a couple of studies that are important. Integration with the NFV management is very far along, and that I will go into details on. Developer community engagement, testing and compliance, etc. Okay. So, why did I want to talk to this conference? Because I think that MEC is the killer use case for zero-touch automation, at least if I take the terminology zero-touch automation at face value. Wrong button. If you look at the characteristics of MEC and what edge computing in a mobile network means, here's what it means. Large scale, geographically, times small scale at each footprint. Now this will depend on, what this actually means will depend very much on a communication server provider. It could be a couple of dozen very large sites. It could be thousands of sites with literally 1 or 2 use of compute. Okay? A lot of these are unmanned, lights-out operations, and they're sort of outside of a traditional service areas. In a lot of cases, they're next to macro base stations somewhere way up on a mountain with an access dirt road. Okay, and while all of this is going on, it's supporting critical infrastructure, whether it's public safety, or just your plain old vanilla mobile telco network. To use an operator, that's critical infrastructure, because if that stuff goes down, you're out some very serious money, right? And now we're seeing requests for KPIs in 9s of availability. So, of course, it is a cloud. MEC is a cloud. But if you go to web scale, guys, and you start checking these things off, let's see, this is completely wrong. When they talk about I went to a Google talk and he said, oh yeah, we operate a global distributed network. We've got, I forget, 10 data centers or something. That's funny. But at extremely large scale, right? Manned. Yeah, they don't have any problem getting people there. They have people there all the time. Not a lot, because that's how they structured, but that's not an issue. They don't really support critical infrastructure. Their compute goes down. They move the workload to another compute. They don't even notice it. And I didn't even mention here, I should have mentioned it, I think it's going to be on the next slide, that these sites are also not as well interconnected as the compute nodes in a data center of a web scale provider, right? So you've got a set of unique requirements and processes that drive a couple of things. You want to minimize the need for a human presence there. I mean, if you could really get to an exact zero-touch automation, that would be perfect. Probably some humans do have to come and visit there, but you want to minimize that. It gets really costly. Maximize service time intervals. If a human has to come out, there's a big difference between saying, hey, here's a ticket, it's Saturday afternoon, you just have to close it before 5 p.m. on Monday, and here's a ticket, it's Saturday afternoon, you need to close it within 24 hours or 6 hours. Big, big cost difference. Minimize skill sets from that are required from those that you sent on site. Again, big difference between a ticket that says something's going haywire, go show up, diagnose it, and fix it, and a ticket that says compute node on rack 5 in location 17 went down. Go to the warehouse, shelf 5, pick a new compute node, go pop that thing in instead of the one that went down, push the green button and leave, right? So in other words, you want to get as close to what the web scale maintenance guys actually do in an environment that is completely non-web scale. Okay? What would this mean? Well, I think it's the sort of the keystones of a zero touch, right? You want to automate stuff so that you minimize human presence, right? You need to do it for your initial startup. You need to do it for ongoing management, workload, so you need to be able to do workload migration, etc. You need intelligent diagnostics in there. This is what's going to allow you to minimize that on-site skills requirement, and you need to be able to predict issues as much as possible. Because if you can predict that something is going to happen, you're going to be able to get that ticket in 3 days ahead as opposed to 6 hours ahead. You're going to be, I mean, none of this is going to happen always, right? But if you can predict problems 50% of the time, which seems pretty lousy, you've just cut your costs about 50%. So this is a big one, right? And that's kind of, to me, when I think about what zero-touch automation means. It means being able to do these things. But then with Mac, the problem gets even more difficult, right? You need to be geographically aware. So when you do these things, it's not just dump it into the cloud. It's very important to dump it in the right place, right? You also should be integrating the geography into this stuff. You know, if there is a hurricane that's being predicted, you should be anticipating problems. It's kind of simple, but web scale guys don't do that, right? Zero-touch automation for a traditional data center environment won't necessarily do it. It needs to be footprint and architecture aware in the sense that in many cases you talk to communication service providers and they think of edge clouds as being hierarchical. There is some compute all the way at the far edge, and there's very little of it. You take a step backwards, there's a bit more compute, right? And while some workloads benefit from being all the way at the edge, you can move them back and they will still work with a very graceful degradation, and others you can't do that with. So in this automation process, you need to be aware of this, right? And this ability to figure out what inter-site workload migration is, it's going to be very important. Now, I'm not talking about application state, migrating application state. That may be necessary, although in my opinion, that's something that you should avoid. It's just what I have a stateless workload, and I need to move it out of that far edge site because I just need to do it, or because I'm predicting that there's going to be a problem. Well, that particular workload I can move, and these other ones I should try and leave there, right? And I said problem prediction becomes very important because it really gets your time to repair. I don't know why I copied that, right? And then you have to be aware of the MEC limitations. WAN connectivity, and it is usually competitive with the user data that's going on. So one example, I give a lot of data center infrastructure management tools, right? One of their basic operations is you push BIOS images when there's a BIOS update that's necessary to your infrastructure. In a LAN environment, you just push it when it's scheduled. If you're doing that simple automation in this kind of an edge compute environment, you probably want to find a time when your WAN consumption is low to push it, or deprioritize it and just push it as you can slowly. Have a place to store it and schedule the actual update at some other different time. And that's, even though it sounds simple, you look at the many commercial products today, they don't have that because that's not a requirement inside, say, an enterprise data center. So there's a bunch of different things that need to happen in MEC differently. All right, what does ETSI MEC provide? Well, I said we are I thought I took this out, okay. No. We are a standards organization, firstly. And from a management point of view, we really build on NFV. So we assume that we're managing a telco cloud. Now, I'm going to say that with a caveat because I didn't talk about the service APIs. The service exposure APIs don't care. But from a management point of view, we're augmenting an NFV management framework to do a couple of things, namely two ways in which a distributed edge is different from what NFV is considered. It's distributed, so there's many little locations, and you need to be location aware, so we've augmented some APIs here, right? And we have a platform for managing these hosts, which in an NFV environment needs to be managed as a VNF. And then we can augment all the other applications for taking into account that there's like a line here, this is centralized, this is distributed, right? So that stuff is going in a distributed side, but also there's third-party applications. NFV is really, I call it inwardly focused. It's focused to the inside of an operator's network, right? Everything is a virtual network function. It's all trusted, tested, and there's some of that here, but there's also going to be third-party applications. If you're going to deploy them inside an NFV managed stack, then they need to be managed like an NFVs. The providers will not deliver them as VNFs, sorry, not NFVs, right? So you need something that can act as an EMS and do all those things on their behalf. So we've got the sort of the APIs for this MEC platform manager standardized and defined, right? So that's kind of the, and you can look into details of this. Now, the nice thing about it is I was thinking about how you know, people often think about these ETSI activities as separate activities, and they formally are separate activities, but in fact, there is a connection here, right? To me, when I think about it I step away as the chair of ETSI MEC and I just think about it as a market participant point of view, ZSM is now looking at an overall approach. How do we actually automate all of this? NFV has defined standards for how to expose services that allow you to manage a telco cloud, virtual network functions inside a telco cloud. OSM is providing an open source implementation of that under the auspices of ETSI, right? So you can kind of see ZSM would be using this, right? And MEC is building on this stuff and extending it to a distributed cloud. So it is in many ways, a continual picture. Now, are there disconnects? Yes. If you want to understand the scope of the disconnects, you can go and look at MEC 17. It's a report we published at the end of phase 1, which did a study on what our disconnects with NFV were, and there were a couple of small ones. In fact, there's work items both in NFV and MEC to fix those now. But you'll also see that by and large, even though this looks like a mess, the big picture was very simple. We've defined these entities, MEC platform and MEC manager, sort of ourselves, but we defined them with NFV in mind already, and they were pretty much a direct fit. So you do have this kind of a picture in ETSI for how everything flows. Oh yeah, and I forgot this one. This is also a management API because with third-party services, one of the things that you need to do is allow the client to request that an application be instantiated near me, right? So that's also there. So conclusions. Success at the edge, whether or not you believe in max standardization, edge computing is going to happen. If you can't manage it with a very light human touch, you have a very costly problem. You can make it work, but I don't know if you can make a business case out of it. Right, so zero-touch automation, I think, is a necessity, or I should say zero-touch in the limit, right, as close as you can get to it. In ETSI, we are developing enablers to this, and to do this in a standardized and interoperable way. That's what standards are all about. And then I do chair MEC, so what is our role? We're focused on the it should say management of a highly distributed geocontextual footprint with a constrained communication edge. Okay, thank you. Yep.
I have one question.
Actually, the microphone? No, we're recording.
Yeah.
Can I just, if you want me to bug you afterwards, let me know who you are, and if you don't want me to bug you, pick your competitor and say that you're them.
I didn't catch. What?
Can you introduce yourself?
Bassem Saedi, Nokia Bell Labs.
Thank you.
Okay, thank you. So I have one question. So for me, mobile edge computing, well, I heard in your talk about web scale, about large scale, but for me, the edge is only a place that is near the antenna, is more or less 10 kilometers. If we want to deploy Cloud Run with all the requirements for run. So it's a IaaS, and on this IaaS, I can deploy whatever we want as a platform. I can deploy whatever I want. And then as workload, I can deploy even the core in the edge. So I don't catch why you say that the web scale doesn't touch. If we know that now, Amazon can deliver an edge node, they call it this bubble, something like that, with FPGA capability and so on. So when you say telco cloud, more or less, even Google Azure now and Amazon are telco cloud. It's not public IT, since I can run a run function in Amazon. So I didn't catch why I heard this logic of telco cloud, this is specific to us, our business, and so on. So can you clarify me this,
Okay.
please?
So, through conversation, a good friend of mine had with people from a large cloud provider. I don't understand why I need all this stuff. Why can't I just put my compute with my management, buy that base station, and do it? And we're done. Oh, sure. What happens when that compute goes down at a 10% failure rate, which is what you're used to deal with? Oh, no problem. I'll just move all the workloads to that other base station. You do realize you're in the middle of San Francisco and you just left 10,000 customers without service. Now, so there's a mindset difference and a design difference. Having said that, there's nothing that precludes these guys, they're very smart guys. Once they understood the problem, they will solve these problems. They still have to solve these problems, right? What I'm pointing out is not a difference between Amazon as a company and, let's pick an operator who is not here. Anyone from AT&T here? Okay. And AT&T as a company. What I'm pointing out is the difference between a distributed edge cloud that AT&T would put out and Amazon's data center. And that's a big difference.
Yeah, but at the end, it's the same logic that we need to have in the edge. I mean, in Amazon or other web scale, we have this cloud platform. We have we call about HA, availability, healing, and so on. All these features, we should have them in the edge. So for me, it's only a feature of the platform.
So you have to be careful. Places like Amazon and Google are designed to support web services. 10% failure rate for compute, and if stuff goes down, I move the workload over in about 5 seconds. You see a problem for vRAN, but that is their management model.
No, the vRAN is a problem if you deploy VM-based, but if you have microservice-based with shared data layer, we have stateless container, there's no problem to move container from one location to another if you have stateless container.
That's fine. What I'm saying is for their containers with stateless containers, if you look at how they manage things, they don't think in the time scales today that, so again, this is not a question about can Amazon can absolutely do it. If you look at the architecture of their web cloud today, right, and you look at the way they approach problems and what their underlying assumptions are, they're very different assumptions that you would have at the edge, and that's what I'm saying, right? It's not about, hey, these guys could never play. Actually, these guys could totally play, and if the telco community doesn't act fast, they will just eat everyone's lunch again. They can totally play. They're already beginning to. But they will do the things that have to be done anyway. They will figure out how to manage something that's at a large geographic scale with a small scale footprint. And they will deploy a workforce that will be able to drive up that mountain road in a few years if nobody else does it. Now, today they don't have it, though. That's not how their web center. So they will, if we don't develop ZTA ourselves, they will develop a ZTA's solution. Now, if you're proposing that we should just let them do it, okay, I mean, that's a business decision. Honestly, the day employer is HP, as long as servers get bought, I don't really care about it.
No,
right?
We need to move on. But
Okay.
I think what you've shown, Alex, is that once again, it's not just about the technology. This
Yeah.
is definitely about operational and commercial considerations, and that's exactly what we
Yeah.
want to talk about here in this event. So thank you for that. Thank you, Alex.
Thank you.
For sharing that.